Hi, my name is Rick Edgeman, and I'm professor and chair of the management department at Fort Hays State University in Hays, Kansas. I also have appointments at Aarhus University in Denmark, the University of Southern Denmark, and have a position with the Shingo Institute, home of the Shingo Prize for Operational Excellence. Today I want to talk to you about quality function deployment, how it is that we extend the voice of the customer all the way from concept, product or service concept, to the marketplace. There's motivation behind QFD. QFD originated in Japan. One of the reasons that it became popular is because it became very obvious over time that using QFD as your product design approach enabled companies to get their products to market sooner with fewer defects and at lower cost to them. Fewer design changes, greater customer satisfaction, and so on. You can see that in this particular graph, which is actually a very famous graphic that displays the sort of relationship that QFD has, or the sort of advantage that QFD has, relative to more traditional approaches that were often used in the West, often, for example, in the US. QFD is not without alternatives. One of the really good alternatives that's out there, but is beyond the scope of this presentation, is referred to as axiomatic design. So what is quality function deployment? There are many definitions that are running around out there. As for me, I developed this one. They're all more or less the same with rare exception. And so I view quality function deployment more or less as a process, and then it's about what that process intends to accomplish. So as a process, what is it? It's a structured method. It's a very structured method. It has an intention behind it. The intention behind it is to transmit and translate customer requirements, which we often refer to as the voice of the customer, all of the way through each stage of the product development and production process, what we call the product realization cycle. And those requirements are the collection of customer needs. Customer needs include things that make them very, very happy, things that surprise them that they couldn't have anticipated. Those are called satisfiers, or exciters or delighters. There are things that make them happy, more is better, or maybe less is better, depending on what it is. Those are satisfiers. And then there are the so-called dissatisfiers, things that customers don't ordinarily even talk about. They just expect them to be okay, and then if they happen maybe to not be there, there's going to be a problem. So when I buy a car, for example, I expect there to be tires and wheels on it. If it's not, I'm going to be very unhappy. Here you can see a simple realization or representation, that is, of QFD compared to more traditional methods of designing and bringing to marketplace product concepts. So what you see, the more traditional approaches would be represented across that top timeline. And you can see relative to the bottom timeline that is crudely associated with quality function deployment, that the planning cycle takes longer. The planning stage takes longer using QFD. It's because we exercise a good deal more care. We're much more careful about elaborating customer needs, for example. We take more time making engineering changes if that's necessary at that stage. So we take more time in planning, but we more than compensate for that extra time in planning later when we use QFD. Because having taken that time early on, that reduces the amount of time that's required to design, to redesign, and ultimately even to manufacture the product, or to roll out the service, or to develop the software package, let's say. So anything beyond that would represent benefits. Now that's only benefits in terms of time. Benefits in terms of getting to market sooner and being able to start realizing profits from your product that you've gotten to the marketplace. What you do not see in that graph, because there's no simple way to represent it, is that you also saved by introducing fewer engineering designs or introducing those engineering designs earlier in the product realization phase, product design phase, and in the redesign phase. Generally, earlier introduction of any changes in your design are less expensive than ones made later. The principal tool for quality function deployment, and often you'll even use this term used for quality function deployment, even though they're not quite one and the same, is the so-called house of quality developed by Don Clausing and a man named Hauser. So Hauser and Clausing developed a house of quality, so-called because of its appearance. I think that's probably obvious enough to you. The house of quality has several rooms. Those are the areas that you see here. The correlation matrix you see at the top and center of this graph is often referred to as the roof of the house of quality. Now, different companies, different software packages will not necessarily have all of the same elements that are used. The one that you see on this slide looks like the one that GE uses. So GE, and this would be common to all houses of quality, would want to elaborate customer needs. That's the one that you see on the extreme left, and that's room 1. What are the customer needs? So we want to take great care to obtain those. Second, though, is we need to understand that all needs are not equally important. What we want to know are the relative importance of those needs. And so that's what you see represented as the importance rankings. And it's very common that those importance rankings are only expressed on a 1 to 5 scale, where 5 would be highly important and 1 would be not so important. And then, of course, gradated from 1 to 5. You see room number 3, design attributes. Well, room 1, the customer needs, we often refer to that part of a house of quality. Whatever is represented over there on the extreme left-hand side, not always customer needs, we'll see that in a few minutes. We refer to those as the what's needed. But we have to determine how it is that we as an organization that is going to roll out this product or service, how it is that we can fulfill those needs, how it is that we can fulfill the what's. So what you see listed here as room number 3, the design attributes, sometimes called design attributes, sometimes called design requirements or engineering requirements, those are the hows, how it is we expect to fulfill the what's. Those are things that are under our direct control. Okay. Engineering operations, amounts of an ingredient that we can put into something, how heavy something is, and so on and so forth. So we would have control over those, and those should all, by the way, be quantitative, measurable along numeric scales. And those numeric scales, at least in the way that GE represents it, are represented down at the very bottom of this house of quality, where you see room number 8, engineering measures. So when you see engineering measures, that would be inches, pounds, feet, millimeters, grams, quantitative measures, pounds per square inch or grams per square inch of pressure, and so on. Quantitative measures of those design attributes. In that sense, we can determine whether we should be having more of a design attribute, less of a design attribute, or some specific amount of a design attribute. More is better, less is better, or target is best. So we'd want something like that. But probably the most important rooms in the house of quality are number 1, number 3, and number 4. We've talked about 1 and 3, the what's in the house. Number 4 is the relationship between the what's in the house. And in each cell in there, you will have either a blank cell, meaning that there's no particular relationship between a specific how and a specific what, or one of 3 symbols. You can pick the symbols. Symbol choice is arbitrary. It could be guided by software choice or something like that. But basically, a symbol for a weak relationship, a different symbol for a moderate relationship, and a different symbol still for a strong relationship. Ultimately, we will then substitute numbers in for those. For a blank cell, we will typically substitute in a 0. For a weak relationship, a 1. For a strong moderate relationship, a 3, and for a strong relationship, a 9. If you recognize that scale, it could be that you've seen the video where we talked about the nominal group technique and we talked about L-shaped matrices, where we substituted in those same values. It's a very common scale. It's a 3 to the power of sort of scale. So you have 0, 1 is 3 to the 0 power, 3 is 3 to the first power, 9 is 3 squared. Very common sort of scale. It's not the only one that could be used. You might find other scales that people have successfully used, but it's one that is common. So fill in the relationships. Other things that would be useful to know: the correlation matrix, which you see up at the top center of this graph, is often called the roof of the house of quality. That is intended to display to you the relationships among the design attributes themselves. And so what we're looking for is it a direct relationship, a positive relationship? As one increases, so does the other. Is it an inverse relationship or a negative relationship? As one decreases, the other increases. Or is there no relationship between them? You can independently do as you please with the two attributes in question. When you have plus signs, what that implies is that there's some synergy that you might be able to leverage between the corresponding design attributes. On the other hand, if there's a negative sign, what that means is there's some disconsonance between the two, that there's some conflict, and that when you increase one, it will be to the detriment of the other. Anytime you have negative signs, what that implies is that you are going to have to make some determinations, hopefully driven by the voice of the customer, about compromises you're going to have to make when you design your product. So an example of a negative relationship might be something like this. I like to have a fast car. I even like that car to sound mean, right? Really mean on the outside. But I also like to have that car have crystal clear sound on the inside when I have the windows up and I'm rolling down the highway. Well, usually what that means is something like this. It means that I'm going to have to introduce additional insulation in, let's say, the doors. And as soon as I introduce that insulation in the doors for the purpose of shutting out outside noise, I've increased the weight of the car. Increasing the weight of the car will, one, it'll negatively affect fuel efficiency, but it'll also negatively impact how fast the car can go because you've increased the weight of the vehicle. That would be a situation where anything that increased the weight of the vehicle but improved the clarity of the sound inside would lead to some sort of a compromise being made. In other words, do you want to emphasize clarity more? Do you want to emphasize speed more? Or do you want to find some golden in-between place for the two? Customer perceptions, usually when you're talking about customer perceptions, that would be how would your product compare to something that's already on the market? And let's see what else is left. Cost and feasibility, number 7 at the bottom. Obviously, it might be that you come up with something, but you just can't manufacture it, an infeasible design. Another possibility is that you come up with something that fantastic design, does everything the customer wants, but they can't possibly afford it. The cost is just too excessive. So we want to have those sorts of considerations. And remember, not all companies, not all software products construct a house of quality in exactly the same way. This is how GE does it. I'll show you something a little bit different as we go through. When we are using QFD, it's common that we don't use a single house of quality, but that we use several subsequent houses of quality. So when we do that, it is called QFD Flowdown. That is, you flow from one QFD or one house of quality into a subsequent one, potentially into a third and or a fourth one. So in a manufacturing setting, a tangible physical product is what you're designing and you intend to manufacture. This is what that flowdown would look like. And in every case, when you're looking at flowdown generically, the hows in one house become the whats in the next house. That's what these black dashed lines are intended to communicate to you. What we have here is a manufacturing sort of setting, and in the manufacturing setting, in the first house of quality, you have the customer needs or attributes being the whats, and the design attributes or design requirements or engineering requirements, however you've chosen to describe those, as the hows. In a second house of quality, those design attributes become the whats, and we determine how those come about through components, specific components of those design attributes, their attributes. In a third house of quality, if we go that far, the component attributes become the what's, process operations the how's, and if you go so far as a fourth house of quality, the process operations become the how's, and the quality control plan or risk management plan or standardization, if you will, standardized processes, become the so-called quality control plan. In manufacturing environments, companies in Japan who use QFD commonly go through all four of these houses of quality. But in the West, it's much more common that you will only see it rolled out through two. So this is what QFD Flowdown looks like when you're talking about different environments. In a manufacturing environment, this is telling you that the customer wants or needs or attributes. So we're talking about the blue boxes over there on the extreme left, that those customer wants are the what's, and the how's are the technical requirements. In the second house of quality, the technical requirements or design attributes become the what's, and part characteristics or component attributes, as we call them on the prior slide, become the how's. In the third house of quality, the part characteristics or component attributes would become the what's, the manufacturing processes itself would become the how's, and in the fourth and final house of quality, the manufacturing process would be the what's, and the production requirements the how's. In a software development or software environment setting, notice customer wants again or customer needs are the what's, product functionality the how's in your first house of quality. In the second house of quality, product functionality becomes the what's, system characteristics the how's. And in the third house of quality, you would only go as far as three. System characteristics become the what's, design alternatives become the how's. In a service environment, similar. Customer wants the what's, service requirements the how's. Second house of quality, service requirements the what's, service processes the how's. Third and final house of quality, service processes the what, process controls the how's. So QFD Flowdown, looking a little bit different for a manufactured product versus software development or software environment versus service environment. So when we build a house of quality, here's what we've got. There are particular things you need to do. Not everything is listed on this slide. You do need to identify the customer needs, customer wants, customer attributes. Step one. Lots of ways you could do that: ethnographic research, focus groups, surveys, customer complaints, and so on. We need that. We need to know their relative importance. We need to identify design attributes or requirements, those internally controllable things that we have that are the how's. We need to determine the relationship between the what's and the how's. Oftentimes, we would evaluate competing products to see how our concept is going to stack up against something that exists already and that's out in the marketplace, or some other competing design that we're considering maybe. And then we would evaluate the design attributes themselves, develop targets, we'll talk about that soon, and determine which design attributes are most important to thoroughly carry out and carefully carry out subsequently. In other of our presentations, other of the videos that you may have seen, we've talked about different ways of obtaining the voice of the customer, and some of those are discussed here. Market research surveys, focus groups, ethnographic research, customer complaints, and so on. And we represent that voice of the customer or the customer attributes over in this room of the house of quality, the what's. In Six Sigma terminology, if you're familiar with Six Sigma, you might call those the CTQs, things that are critical to quality of the product from the perspective of the customer. And by the way, these what's, these customer needs, are usually expressed in the language of the customer. So this represents the voice of the customer. Customer importance, that should be not from the company perspective. That should be from the customer perspective. So you're going to have to then identify design attributes. What is that's internally controllable to the company that you believe will be able to help the company fulfill the desires, the needs, the wants, the customer attributes. Those are the so-called hows. The hows and the whats, the relative importance of the whats, the relationship matrix right here. The relationship between the whats and the hows, how do they map with one another? There are some other things we'd want. Conflict resolution. I've talked about conflict resolution a little bit. The idea that we were talking about in conflict resolution was to look at this correlation matrix. And when you look at this correlation matrix, the question would be, do I have any negative relationships? So here I've used a simple symbolic representation. The symbols are up to you. But simple symbolic representation, if there are any negatives that are here, and you see some, here's some double X's, here are some other X's, there they are, strong negative and negative. That's when you have to have that further discussion about compromises that you're going to have to make among the design attributes themselves and how much of which ones to roll out. Here in the body, what you would be seeing is something like this. I chose a simple symbolic representation. This would represent the relationship between need number 1, which was a very important need, 5 on a 1 to 5 scale, and how number 1. So the relationship between need number 1 and how number 1 is, let's say, high, H for high. What would that mean? It means that this first design attribute right here is going to do you a lot of good in trying to satisfy that customer need. How number 2, on the other hand, only a little bit of good, low. Empty cell, how number 3 does nothing for you, how number 4 does nothing for you, how number 6 does nothing for you, relative to fulfilling need number 1. But you do see that how number 5, a little bit of help, and a moderate amount of help from how number 7. You're probably asking, how did you get this number over here, this 70, or down here, these numbers? It's actually straightforward. I prefer to add a few more columns to these, a column here and a row down here. I'll talk about those in a minute. They're not on the slide, but they will nevertheless, we'll talk about what you could put there. So let's get this 70 first. High, 9. Low, 1. Blank cells, 0. Moderate relationships, 3. So the way that we get 70 is 5 times 9, 45, plus 5 times 1, another 5, we're up to 50, plus 5 times 1, another 5, we're up to 55, plus 5 times 3, another 15, we're up to 70. Similar up and down here. The 57, 41, 48, and so on. How did we get, let's say, the 57? 5 times 9 plus 4 times 3. 45 plus 12, 57. Generally speaking, what you have is, as you look at these numbers over here, the row totals or the row values where you see 70, 45, 21, and so on, the higher the number, the better the ability of the design to meet the corresponding customer need. Low value is bad, high value is good. On bottom, generally speaking, the higher the value, the more useful the corresponding design attribute in satisfying across a range of customer needs. Now, what I actually prefer more than these weighted values, I actually prefer the raw values. So what would I have for a raw value here instead of 70? That's a weighted value. I would have 9 for high, plus 1 for low, plus another 1 for another low, plus another 3. I'd have 14 out here. For the next one, I would have only 9. For this one, 3 plus 3 plus 1, 7. And out here, you would have the raw abilities. The raw abilities of these design attributes to fulfill customer needs. The higher the number, the better. But you could make a straightforward comparison of your relative abilities to fulfill need 1, need 2, need 3 across the range of needs. Similarly down here, what I prefer, rather than the 57, 41, 48, and so on, the weighted design attribute usefulness, I prefer to just add the values. Here's a 9, here's a 3, I would have a 12 down here. A 1, a 9, I would have a 10. 9, 1, 1, 11. 3 and 1, 4. 1 and 3, looks like I left something out. That would be a 4. Okay. This one would be 1, 3 more is 4, 9 more, 13. And this one would be 6, 3 plus 3. The bigger the number, the better that the corresponding design attribute does, or more generically, the better the how does at satisfying across a number of customer needs. So I prefer those raw numbers. I think personally that they are more useful. But you're still going to have to relate those design attributes and the customer attributes as well. And that's what we were just doing with the high, the medium, the low. I don't care what symbols you used. I just chose to use letters that were hopefully communicative for you. So those were the relationships. And notice that we would have a key that would say what those symbols correspond to. But notice that we didn't just directly enter the numbers, the 9s, the 3s, the 1s, for highs, mediums, and lows. We saved that. And the reason that we saved that is because when you're populating this matrix right here, the relationship portion of it, we want you to focus on the strength of the relationship, not on some number. Only focus on how strong is the relationship. Oh, there is no relationship, a blank. Yeah, it's pretty weak, it's moderate, it's strong. Focus on that, not on the numbers. The numbers will come later. Add market value and key selling points. Useful. We're not going to talk about that much. Evaluate the design attributes of competitive products. Set targets if you can. Remember that we want our design attributes to be measurable, quantitative. So what you saw down here would be how much. If you saw that, it would say ideal would be 3 pounds, ideal would be 12 inches, ideal would be whatever that is, 3 mils. Ideal would be 40 pounds per square inch. Something that you would ordinarily have accompanying that would be something like this. You see the up arrow, down arrows, and here you see a circle filled in. This would just say that more of that design attribute is better, less is better, less is better, more is better, less is better, less is better. Some target amount is best. And we would have values typically that would show us what's ideal. So that would be the target directions. And then lastly, you'd say which of those attributes were most important. So which are important, generally speaking, it's going to be the ones with the highest values down here. These values, the weighted values that we talked about, how it is you compute those earlier. If you need a formula, there it is. These are called technical importances, and it says that the technical importance for any given design attribute is to take the customer importance rating, multiply it by the strength of the relationship, and then add those up. And that's what we did. Remember that we had a 5 for the importance of need 1, a strong relationship, that was an H. The numerical corresponding value, a 9. 5 times 9, 45. 4 times this was a moderate. 3 is 12. 45 plus 12, 57. Bigger numbers, more importance for the attribute. And then these are typically called completeness numbers and obtained in the way that we described previously. Remember, I actually have a preference for the raw completeness values. This would have been 14, this would have been 9, and so on. And I have a preference for the raw the raw technical importance values down here, where you would have had, for example, instead of 57, you would have had 9 plus 3 is 12. Because I think that those are just more informative, frankly. And then using the house of quality. This is something that should be said about any tool that we use. The tool is intended to provide guidance. In the case of the House of Quality and Quality Function deployment, it's actually meant to provide very exact guidance, but generally speaking, still, it is not the decision maker. You or the design team, you're the decision makers. Okay? And you're making your decision in a way that aligns with explicit customer needs. Let the House of Quality, let QFD guide you in your decision process, but don't let it be the final decision maker. And that's about what we've got on quality function deployment. So in another video, we'll talk about an example associated with Comic-Con of how it is that we might be able to deal with these things. Thank you.